Alrighty, week eight. Week eight. Hard to believe. But here we are. Last week of the course. Pretty crazy. But it's been a heck of a lot of fun, and I want to keep the fun going one more week, which should be cool because we're trying to hit the topics now that you guys either suggested or endorsed or otherwise seem to be something that you think you'd be interested in. So, psychology is just so broad that we could probably have 3 or 4 all request weeks like this and just kind of keep going. But we'll do what we can with this week. I want to be quick because this is the 3rd time I've tried to tape this video. The other 2 times I've went a half an hour. So I'm going to try to be a little quick, a little more efficient. In fact, let's get right to it. All right. So, Week 8, Lecture 1. The first lecture is going to be on sleep, but really what I'm imagining now is for the next 3 lectures, a little package, I guess you could call it, that we would say is on altered states of consciousness. In every intro psych chapter there is, or every intro psych textbook rather, there's a chapter about consciousness where they almost always focus on these altered states. And they are all kind of cool, interesting things. And on top of being kind of cool and interesting, they, to some extent, show us the limits of psychology, especially when we get more into the dreams and the hypnosis side. So throughout, I'll be able to give you a little bit of science, but it's going to be mixed with a bit of speculation because you're going to find out that, to some extent, there are limits to what we can learn when it comes to the human mind. Okay. Now, on that sort of perspective, what we know about sleep to some extent is probably the most scientific, sort of. Let's kind of jump into that. At some point, researchers realize that the brain, and we've talked about this before, the brain is essentially an electrochemical machine. Everything that happens in the brain, all the information that's transmitted, is transmitted via charged chemicals moving around. And we talk about axons firing, releasing a charge, and they do. And it turns out this electrical activity in the brain can be measured. So there are these devices. You can see one pictured over her shoulder here called an EEG electroencephalogram. Essentially what an electroencephalogram is a bunch of little tiny microphones that can pick up electrical activity that's going on the other side of your skull emanating from your brain. Now because it's got to go through the skull, it's very hard for us to know exactly where these signals are coming from. We can't get really specific about where the signals come from. But it turns out that just the electrical activity of the brain in general, the hum of the brain, if you will, seems to change in a very systematic way as we sleep at night. So this is one of the first real nice concrete objective measures we've had of the sleep process. And in fact, we can learn some really interesting things from it. So, as depicted here, you can think of sleep as being 5 different stages, it seems, at least when you look at the electrical activity. 5 stages that then repeat over and over, but they don't repeat in a static way. The brain doesn't do much in a static way. It tends to be very dynamic, always changing. And in terms of these sleep cycles, that's true too. But I'm kind of getting ahead of myself. So let's go a little slow. And let's just imagine you've had a hard day, you've been studying psychology all day, your head hits the pillow, what happens? Well, initially, at the very beginning, and see it just says sort of 4 to 5% of this whole cycle is spent in what we call stage 1, or very light sleep. And this is really just you kind of relaxing into the bed. So your muscle activity slows down, you're starting to get a little comfortable, and at this stage occasionally we have those little weird muscle twitches that happen. I don't know why. If you look at the brain electrical activity, it doesn't look that different from when you're awake. And what I mean by that is we have what are called high frequency, low amplitude. So high frequency means we have a lot of activity going on here. So, a lot of quick little bursts, but none of them are very big. So they're low amplitude. Not a flat line. There's definitely stuff happening, but it's happening really fast, but kind of really sort of small amplitude stuff. As we get into deeper sleep, And let's just kind of look across the stage 2, stage 3, and stage 4 here. what you see is that the frequency of these waves starts to get larger. That means they spread out a little bit. You can really see this by stage 4. And the amplitude, how big these waves are, increases. They get bigger and bigger. In fact, by stage 4 here, we're going to call this delta wave patterns. These big, high amplitude, low frequency waves. And so you can kind of, as we go across these stages, you're kind of seeing a transition from here to there. All the way through, you see what are called these little spindles. Every now and then there's these bursts of electrical activity. But we're going to focus more on the general pattern and less on the spindles. All right, so early on, high frequency, low amplitude. Then we hit stage 2. This is where we're really starting to get to sleep now. So our breathing and our heart rate are going to slow down. Our body temperature is actually going to decrease a little bit, and these waves are going to start spreading out and start getting a little bigger. Now, we're really asleep when we hit stage 3 and especially stage 4. Stage 4 is often called deep sleep, or both of these together are sometimes called deep sleep, deep and very deep. This is when the brain starts to generate these waves, okay, these really big delta waves. And as suggested here, your breathing becomes very rhythmic, your muscle activity becomes very limited. In fact, there's something really interesting that happens somewhere near the end of stage 4. All the way through these stages, your muscles are a little relaxed, chemically relaxed. Okay, literally there are hormones released that kind of, for lack of a better word, begin to paralyze your muscles. And by the end of stage 4, that paralysis tends to be very deep. Why? Because stage 5 is where dreaming happens. So you see a dramatic change in the brain electrical activity. It suddenly goes back to something a whole lot more like stage 1, both of which, by the way, are very similar to how it would look when you're awake and alert. So you go into the dream state, and it's like you're awake. And it's like you're experiencing information, but the experience is no longer coming from the external world, it's coming from the internal world. You're experiencing a dream. In your dreams, you act. The reason your body paralyzes, or your brain paralyzes your body, is because you don't want to be acting in your sleep. There are people for whom, and we'll talk about this a little bit at the end, this paralysis doesn't work. They do act out their dreams. And I tell you, you do not want to be in bed with somebody whose paralysis is not working. They will thrash and they will throw their arms around, and if you're in the way, too bad. Okay? That's what this paralysis does for us. It allows us to have this rich interactive dream experience while our body stays there relaxed. So kind of cool. All right? Then we go through our dream, and then we kind of go back to stage 1, sort of. In fact, if we now transition from this diagram down to the one in the lower right, what this one in the lower right shows is a better representation of what might happen during a night's sleep. So somebody spends, think of the length of these bars, the horizontal length is how long they spend. So at first you go to bed, you're awake for a while, and then you go down to stage 1 for a little while, not very long, quickly drop to stage 2, sorry. You're sleeping a little bit more. Now you're getting into this deep sleep, and then finally you get down to stage 4, which is that very deep sleep. And notice you spend quite a bit of time in stage 4. Now you go up. Now notice in this case the person didn't seem to go right into the dream state. They seem to spend a little bit of time in stage 2. Sometimes this happens, but then they go right up, and this is the dream state, stage 5. Okay? So that whole cycle took them from here, to here to complete. And then they start to repeat the cycle, but not exactly. So notice they don't go to stage 1, or actually they kind of have the dream as being akin to stage 1 here. But they go down to stage 2, and then they jump all the way down to stage 4 here, stay in deep sleep for a while, back up to stage 3, up to 2, back to dream, back to 2, back down to 3. They don't even go to deep sleep in this cycle. They go back up to dreaming, etc. And what you see is that early in the night, it seems like that stage 4 is really important. So we spend a lot of time in stage 4 and relatively not that much time dreaming. But as the night continues, we spend less and less time in deep sleep and more time dreaming. Okay? So that pattern, how much time we spend in each of those stages, shifts. Deep sleep is important early in the night. It seems like the first thing your body wants to get. But once it's gotten lots of deep sleep, then your brain starts to play and you have lots of dreams. All right? So we can tell that very well from the electrical activity. There seem to be these demarcations, these changes. We also know, by the way, there's external evidence. When people are dreaming, so it has the D here for dreaming, but up here it's got REM. What that stands for is rapid eye movements. Because when people dream, if you could look at their eyelids when they're dreaming, I'll try to let you do this. I have no idea how this will come across. But when they're dreaming, their eyes are going all over the place. And in fact, if you were to wake them up, if you paid close attention to their eyes, and especially if you saw something interesting, like let's say they were doing this. I'm trying to do an up and down motion with my eyes, but I don't know if you can see that. Okay, and you wake somebody up and you say, what were you dreaming? They might report, oh, I was watching these kids on pogo sticks and they were bouncing around. You know, something about what they said they were dreaming would match with their eye movements. And so you can actually see that something interesting is happening. And in fact, if you wake people up while they have this rapid eye movement, while they're exhibiting, you know, this kind of brain pattern, they will report a dream. But if you wake them up in this brain pattern, stage 4, they won't. And in fact, they'll feel horrible. When you wake them up, they'll feel, remember that paralysis I was telling you about? They'll feel like, oh my goodness, I don't want to wake up now. I feel exhausted. I feel tired. That feeling that you sometimes have, waking up and feeling horrible, that's because you woke up in stage 4. If you wake up from a dream, you tend to feel pretty good. That's the natural place. That's where your brain is most like it is when it's awake anyway. So these stages seem to be distinct. Okay, well that's kind of cool. Feels kind of scientific. What's it all mean? Why do we do this? Why do we spend a third of our lives asleep? You know, pathetic, really. You know, a good well-armed rat could kill us while we're asleep if it knew where to bite. You know, why do we do that? Well, that's a real puzzling question. And I can give you a bit of the answer. There was an interesting study done on marathon runners. And of course, the interesting thing for marathon runners is they come to marathons from all over the world, which means, of course, that they've had a variety of good or poor quality sleep before a race. You know, some of these people are very jet lagged. They've been traveling for a long time. They haven't slept well. They're not feeling well rested. And so one question is, well, if good sleep is all about repairing your body, which is something that seems possible, you know, after all, when people are really, when they have some major health attack, like a heart attack, for example, they tend to sleep a lot. So it seems like sleep fixes something, right? Well, when you look at these marathon runners and you ask how well do they run compared to their average, and does the amount of sleep they've had before predict that, the answer is no. Okay? The runners who've had very poor sleep seem to do just as well as the ones who've have slept very, very well. This sounds like a digital lab coat thing, right? Amount of sleep for, say, the week prior to your marathon does not predict how well you'll do in your marathon. So it just seems like it doesn't matter. In fact, a lot of what people might think of as simple tasks, like running a marathon, you don't have to think too much. There's a bit of strategy involved in running a marathon, but for the most part, it's about just doing it, right? And in situations like that, simple motor tasks, lack of sleep does not seem to impair performance. However, if you have a complicated cognitive task, something like, say, an air traffic controller, where you have to look at all these constraints. I have this airplane coming in from that direction, with this much fuel, that airplane coming with this much fuel. Who do I allow to land when? How long can I leave that airplane out there while I'm waiting for other things to happen? When you have these complex, you know, high risk, complicated situations, now sleep matters. Somebody who has poor sleep tends to do much worse on complex problem solving than somebody who's had a good sleep. So it seems like sleep is important psychologically, maybe more important psychologically than physically. And we still don't completely understand it, but that seems to be part of the story. And in fact, people have been able to tease that part a little bit more, at least in terms of memory. We know, as we've talked about before, that the hippocampus is critical for memory. But those sleep cycles, those stages I've shown you, they seem important to memory as well. And there's some interesting things we can talk about here. So the first one is just the general notion of consolidation, what's called consolidation. The idea behind that is this. If you learn something, and let's say we have two groups of people, and we have them both learn something, say a list of words even. They both learned a list of words. Now one group we allow them to sleep for 8 hours. The other group we don't allow them to sleep. We have them do some task that's not too interesting. We don't want to cause any interference by having new learning going on. So nothing like that. Maybe they just play Tetris for a while or something. Now we test their memory of what they learned. And what we'll find is that the people who sleep remember better. Sleep seems to somehow aid learning. And the theoretical notion people postulate is something called consolidation. The idea being that you learn all this new information in a day, but that your brain at night somehow reorganizes that information. It stores it away in a way that makes it easier to access later. It consolidates it somehow. Vague idea, but people think sleep does that. And in fact, the different stages of sleep seem to work on different kinds of memory. Remember episodic or semantic memory, especially episodic really in this case, the learning of information. This lecture, okay? What have you learned about sleep in this lecture? Well, it turns out if we gave half people this lecture, well, we have two groups. You both watch this lecture. I have to say this right. Now, we let you both sleep, but we do one thing to one of your group. We prevent you from getting deep sleep. As soon as you start to go into stage 3, we wake you up. Annoying as heck, brings you back to stage 1, stage 2, you get to stage 3, we wake you up. Okay, but back to stage 1. So we never allow you to get that deep sleep. If you start dreaming, we allow you to dream. That's cool. We just don't allow you to get the deep sleep. If we do that to you, then you will not learn information very well. Deep sleep seems really important to consolidating information. Dreaming seems very important to consolidating skills, procedural memory. So, what I always think of when I think of this is when I started playing bass and I was trying to learn how to play bass. And you have to learn all these finger positions and things to do with your other hand. And I would learn all these various patterns associated with various songs. When I'd go to bed at night and go to sleep and dream, I would dream of playing the bass. Everything I'd learned during the day, I'd be repeating in my dreams, and it would be going over and over again. It seems dreams somehow consolidate that procedural memory. If you don't allow someone to dream, you keep waking them up every time they dream, they will show poorer learning of procedural memory. They'll learn information fine, but they won't learn the skills. So deep sleep consolidates information. Dreaming consolidates skills. Kind of cool. I mean, we still don't have a good feel for what's going on, but at least we're starting to get the sense of it. All right. Now, just a couple things at the end here that I want to talk about quickly. One of them is just at a higher level, the importance of sleep, as you'll often see most dramatically demonstrated by people who have trouble sleeping. We all know this look that this woman's giving the clock, like, oh my goodness, I need to sleep. I have an important day tomorrow and I can't sleep. Why can't I sleep? Insomnia. Horrible. People who suffer insomnia, that gives rise to all sorts of health risks and all sorts of problems. It is often associated with worry, guilt, or stress. So if you have a lot of any of these things in your life, you may have insomnia. It can also be associated with just having a very non-structured life. The best way to avoid insomnia is to wake up at the same time every day, go to bed at the same time every night. If you lead a very structured life, your body will sync up to it. But if you don't, and I think of somebody like Michael Jackson now. Michael Jackson, you know, on tour, big superstar, moving all over the world, doing things at ridiculous times, being asked to do press stuff, being asked to do this, practice, practice, practice. And then at some point his handlers are saying, oh, we don't have anything for 8 hours, so go get some sleep now. Well, when you lead that kind of life, you have trouble. We can't just sleep on command like that. Our body has to be kind of ready for sleep. And so, you know, often those people will start to rely on some sort of drug or sleep medication to help them sleep. In Michael Jackson's case, it got so extreme, he was actually using surgical anesthetic to try to knock him out. And that's what ultimately killed him. So, you know, it can be pretty, this just shows, I think, the importance of sleep to humans. By the way, if you deny them sleep, I think after something like 20 days, they die. We still don't know why. At some point, they start getting sores, their body temperature isn't regulated well, and they eventually die. We need sleep. We still don't know why. We need it. Another interesting kind of thing, aside from insomnia, is something called parasomnia. So I'll just mention this in case you're interested, but it relates back to that paralysis process that I talked about, and we're going to bring that back in the dreaming one. But there's all these weird parasomnias which refer to somebody who is acting like they're awake when they're asleep. And we think of sleepwalking as the prototypical parasomnia. Sleepwalking is very common in younger children. And again, it seems to be because the body doesn't paralyze the muscles. It still seems to be happening in stage 4. Okay, if you wait, this is why they tell you not to wake somebody up when they're sleepwalking, because they're in stage 4. And if you wake them up, you know, normally they would already feel horrible and tired and groggy, but you know, if you wake them up and they're standing up in their kitchen when they're supposed to be in bed, now they're completely confused, completely disoriented, tired as heck, feeling groggy, and that's why it's sort of a bad thing to do. It's better to put them back into bed and let them carry on with their sleep. But there's other weird things people do. They sleep eat. They have sex while they're asleep. There's something called sexsomnia. Check it out. Kind of freak you out. It's kind of weird. And these all seem to have to do with the body not paralyzing properly. So it's kind of cool, interesting stuff to look into. All right. I don't know how much I went on. I tried to be faster. One of the things I cut out, but I stuck it in the video, is the notion that sleep really falls into a bigger picture called circadian rhythms. It's part of the general rhythms our bodies fall into. When I said it's good to have a regular lifestyle, when you learn about circadian rhythms, get a sense of that. This video will show you the EEG in a sleep lab in a lot of detail. So it'll give you a really good sense of how we do brain recordings. This video talks about sleep deprivation as a sort of scientific manipulation, preventing people from getting certain kinds of sleep. So I talked to you a little bit about that. Check that out. And for those of you who suffer from insomnia, this music theoretically will induce your brain to fall into those big delta waves that will give you deep sleep. So you can put that on before you go to bed, and maybe I'll help cure your insomnia. On the reading side, this one's just a general resource that talks about a lot of the things I talked about, and also specifically how much sleep you should be getting. This is kind of a fascinating website if you have an iPhone. It will analyze your sleep patterns, your stages, via your movement, and it will wake you up when you're in the right stage. That is, when you've just completed a dream, it wakes you up. So instead of setting your alarm for 7, let's say, you can set your alarm for, well, I would like to wake up around 7 whenever I'm just completing a dream, please. And the app will do that for you. So it'll prevent this wake up when you're not ready for it and feeling like crud, theoretically. And finally, I have this thing that relates back to the circadian rhythms thing. I'm just going to let you take a look on that on your own and think about that. Alrighty, cool. I am going to shut up now. Hopefully I didn't go on too long, and we'll come back for dreams. Alrighty, cool. I will see you in dreamland.